right, so today we're going to look at 5.5, which is called the dot product. Now, at first, we're just going to practice the dot product. I will show you after what the use is for it. Okay, we do use it to do something pretty simple, but we'll get to that after. All right. So suppose that we have two vectors, and that's in IJ notation. Vector V has a horizontal part of A1 and a vertical of B1. And W has a horizontal of A2 and a vertical of B2. Okay. In a problem, those would all be numbers. Like, I don't know. I'll show you an example after. But they would just all be numbers. A1, B1, A2, and B2. All numbers. Like 3i plus 4j and 12i minus 8j. Something like that. Okay. So if you want to take these two vectors and multiply them together using what is called a dot product, first, that's the notation that you use. Okay? Bold V, because that's a vector. Bold W, and you put a dot between them. Okay? And yes, you have to put the dot. Okay? It's not like sometimes in, especially in like elementary school, you might use a little X for multiplication. If you wrote this, that means something totally different. That's called a cross product, right? We're not doing that today. So we're doing a dot product. So since there are two ways to multiply, you have to be specific which one you want to do. Okay? So if somebody said to me, multiply these two vectors together, I would say how? With a dot product or a cross product? We're looking at dot product. So to multiply these two vectors together as a dot product, you take the two numbers that represent the horizontal components, multiply those together, plus, and then take the two numbers that represent the vertical components and multiply those together. And that's the formula for finding a dot product. So you multiply two things together, you multiply two other things together, and you add them up. So we just said that A1, A2, B1, and B2 are all numbers. So Anthony, what do you get in general if you take something that's a number and multiply by a number?
Bigger number.
Another number. It could be bigger, it could be smaller, but you get another number. So when you multiply a number times a number, you get a number. Multiply a number times a number here, you get a number. What do you get when you do a number plus another number? Another number. So the point here is when you do the dot product, the answer is a number, like 5. That's what the answer will look like. Right, so multiplying two vectors together as a dot product gives you a number for an answer. Now that number means something. I'll show you later what it means. Okay, so here's two vectors. 2i minus 3j and 5i plus 3j. And I want to find the dot product. V dot W. Okay. So what I usually do is just start like this, then fill it in. Following that formula right there. Right, so Abigail, what would be the number in my first parenthesis? So here's our formula we're using. And here's the specific numbers that we're going to plug into that formula. So we have these 4 numbers, and they're going to go in those 4 spots. Do you know which one is going to go in for A1? Just the number. So just the 2. Yeah, just the 2. How about Riley? What's going to be my next number? 5. A1, A2. A1, A2. You got those ones. Next one, B1, B2. Alex, what's gonna go right here in this case? Yep. No, actually, I'm sorry. 3 is B2.
Oh, okay.
-3. Yep. We'll see in a second if that would have made a difference. All right. We'll check that. So A1, A2, B1, B2. And now we'll just simplify. Grace, what's 2 times 5?
Oh, sorry, 10.
Yep, 10. And -3 times 3, Isaiah? -9. So Emily, what's the dot product between those two? 1. That's it. Nice. And that's all you have to do to find a dot product. Any question on how we got that? So that's V dot W. Let's switch it around. Let's try W dot V. What do you think I'm checking for here? We mentioned this property on Monday. Checking to see if the dot product is what? Yeah. I'm checking to see if it's commutative. Checking to see if the order you multiply them in matters. Let's see. All right. So this time, Stephen, what would be my first number in the parentheses?
5.
5, right? Now you're starting with the bottom one. So 5 is the first one. 2 is the second one. So 5 times 2. Jason, how about my first number here?
3.
Yep, 3. And my second number? -3. Now, when I do the dot product there, what am I going to get? Which is? 1. Still 1. So the answer to the question, is the dot product commutative? Yes. Commutative. Got a little cut off. Right, but yep, the dot product is commutative. So V dot W does equal W dot V. Now, we don't know this yet, but when we do the cross product, that'll be the last one we learn tomorrow, it's not commutative. The order changes the answer. All right, let's try another dot product. V dot V. So this time we are dotting a vector with itself. Still do it the same way. V is 2i minus 3j. Just copy it down. Anyone think they could tell me what I would fill in for V dot V? Yeah.
2 and -3.
So 2 here and,
-3.
well, this has to be a horizontal and this has to be a horizontal. That's a vertical, that's a vertical.
So they're both 2.
Okay, yep, 2 times 2.
And both -3.
And both -3. It's like you're using the same vector twice. Now, what's another name, or what's another way you can write 2 times 2? 2 squared. 2 squared plus -3 squared. Did anyone see what that kind of looks like? Square something else, and then add them up. When do we do that? I mean, it's missing the last thing that we do usually, but it's pretty. Other than that, it's pretty close to it. Yeah. Right. It's like Pythagorean theorem, except you're not taking the square root. You're squaring something. You're adding them up, and you're just stopping. You didn't take the square root. So this would give you 4 plus 9. Or 13. If you took the square root of 13, what would that be? Not as a decimal, but like it would be the what of vector v if you took the square root of it. It would be the, what about the hypotenuse? The length, exactly. Good. It would be the length. So when you dot a vector with itself, it's almost like you're finding the length of it, except you're not taking the square root. That's just the way the pattern works. So this dot product is 13. The length of vector v is square root 13. All right. Let's do w dot w. All right. So w is, just to remember, 5i plus 3j. 5i plus 3j. So Emily, what would go in my first two sets of parentheses? Emily.
What?
Hi.
Sorry.
It's okay. Welcome back. If w is 5i plus 3j, what number that's the same would go in both of those parentheses?
3?
The 3 is going to go in the second one because that's the vertical.
Oh, 5.
But the first one would be 5. So it's like 5 squared plus 3 squared. We're just not taking the square root. So that's going to give me 5 squared. How much is that, Isaiah? 25. And Stephen, 3 squared? 9. 25 plus 9 gives me a dot product of 34. Any question on how we got that one? So that happened both times. When we dotted a vector with itself, you end up with the same number here times itself and the same number here times itself. So what that means is if you dot a vector with itself, you're not getting the magnitude. Because to get the magnitude, you'd have to take the square root. You're getting the magnitude squared. So dotting a vector with itself almost gives you the magnitude. You just didn't take the square root. So it's actually the magnitude squared. And you could write the same thing. W dot w equals the magnitude of w squared. You could write it with whatever letter you use. Doesn't matter. All right. So let's find this dot product. This time it's not written with I and j. It's just written in the other notation. Vector 2, 6 dotted with the vector 0, 0. What's going to be the answer here? Can you be more specific? How about this question? What kind of answer do you always get when you do a dot product? One of the first things I mentioned about dot product. No, not a length.
Number.
A number. So when you do a dot product, the answer is always a number. So Isaiah said 0. And the way you get it is you do 2 times 0 plus 6 times 0, which is the number 0. Not this. That's a different kind of answer. That's 0, but that's 0 the vector. We talked about that on Monday. Or you could make it a bold 0. Okay. So when you add or subtract vectors, you can get the 0 vector. That's when you have two vectors that are the same length but point in opposite directions and you add them up. That would be this. Okay. But when you do a dot product, the answer is always a number. Okay. So just be careful for that if I asked you something like that on a test. Dot product, the answer is always a number. So the number is 0. All right. Distributive property does work with dot product. We don't tend to really have to do it a lot, but if you had to, you could. You can do u dot v plus u dot w. Just like a distributive property you learned in Algebra 1. It does work fine. So what that basically means is you have options. If I gave you 3 vectors and I asked you to do this, you could either add the vectors first, like we learned yesterday, and then do the dot product with what you get with the addition. Or you could say, forget it, I'm just going to do the dot product with v, I'm going to do the dot product with u, and then I'm going to add those two numbers together. You could do it either way. All right, so what the dot product is actually used for is to figure out the angle between two vectors. Here's a vector, here's a vector. Where I put that question mark, that's what I mean by the angle between. It's always the angle between. It's never the angle on the outside. It's always the small angle. So, to find the angle between two vectors, there's 3 steps. Plus 3 calculations. You have to find a length, you have to find another length, and you have to find a dot product. All 3 things we already have learned how to do. The lengths we learned yesterday, dot product, I just showed you. And that's the formula for how to find the angle between two vectors. Now, you'll notice it doesn't say theta equals. We've got this cosine. So the very last step in any problem is to get rid of cosine. And we've talked about the function that cancels out cosine. Right? So we'll use that as our last step. But the first thing you want to do is find the dot product between the 2 vectors I give you. Find the length of the first one, and then find the length of the second one. So remember, the denominator, those are just lengths. Length of u times length of v. Now, in general, 2 vectors usually just make a random angle, like 34.5 degrees. It's usually not anything special. Sometimes it is. Sometimes they come out perpendicular. Sometimes they come out parallel. I'm going to show you guys how you can tell specifically if they're parallel or perpendicular. And there's sometimes a little shortcut for that. But for now, we're just going to do a random angle. Okay, just some decimal. Hey, everyone have the formula? All right, so here are the 2 vectors. And what you're going to probably see on the test, you're going to see one more step in this question. I'm going to ask you, are the vectors parallel or perpendicular? So the first step is to find the angle. If the angle comes out to 90, then they're perpendicular. If it comes out to something else, which I'll tell you later, then they're parallel. Okay. So let's start with our dot product. Okay, so remember, you're going to find the dot product, find the length of u, and then the length of v. Okay, so it's not, as long as you get a calculator, it's not too bad. Pat, can you tell me first 2 things that I would multiply to get my dot product?
4 and 2.
Yep, perfect. 4 and 2. Elizabeth, the next 2 things?
3 and 5.
Say it again.
3 and 5.
One more time.
3 and 5. -3.
-3 and 5, yeah. Unfortunately, if you mess up one part of the whole thing, then the angle comes out wrong. So just make sure when you grab it, grab the sign that goes to the left with it. So -3, +5. All right, Yushira, 4 times 2 and -3 times 5, which gives me a dot product of
Is it -7?
-7. Right. So there's our dot product. Now, with just the dot product, you can't tell what the angle is yet. Now we need length of u. So this is what we did yesterday. Gabe, when we found the magnitude, what theorem did we use? From geometry. And we talked about it when we talked about dotting a vector with itself. It's almost like doing this theorem. You want to help them out?
the Pythagorean theorem?
Right, it's the Pythagorean theorem. So we're going to use the Pythagorean theorem to find the length of u. Alright. So, whenever we do Pythagorean theorem, what's the first thing I should write down? Everything's going to go under this. Yeah.
Square root.
Yep, you're going to start with the square root. And now it's the square root of each component squared added together. Right. So how about, Alyssa, what's the horizontal component in u?
4.
And the vertical? -3. Take each component, square them, and add them up. So Andrew, 4 squared gives me how much?
16.
Yep, and -3 squared? 9. And 16 plus 9 gives me 25, and the square root of 25 is 5. Most of the time that does not happen. Most of the time you end up with like square root of 10 or something. Okay, you end up with a decimal. But it did happen here. Okay, so now I get the length of u. Now I need the length of v. So Courtney, could you tell me my setup to find the length of v?
2 squared and then 5 squared.
Let's see, I forgot what it was. Yep.
Or
2 squared plus 5 squared. So that's just going to be the square root of 29. We're just going to leave it like that. Okay. So now you've got the 3 things that you need. The dot product, length of u, length of v. Fill them in right there. Dot product, length of u, length of v. And then set it equal to cosine theta. All right, so let's do that. All right, so dot product was -7. Usually the dot product comes out nice. As long as your original problem didn't have decimals, then your dot product won't have decimals. The bottom usually does not. The magnitude of u is 5 times the magnitude of v, square root of 29. Now, if I type that in on a calculator, this whole right-hand side, that's not my angle. That's the cosine of my angle. So how do I get rid of cosine?
inverse.
Exactly, nice. Take the inverse cosine. Take the inverse cosine. That's my angle. Inverse cosine of -7 divided by 5 root 29. You can just, I mean, if you've got a calculator that you guys use, you can type that in one step. All right, first I'm in degrees, that's fine. I'm going to do the answer in degrees. So -7 divided by, you just have to be careful that you put a parenthesis for the denominator. 5 square root 29. 29. All right, so that closes my denominator, and that closes the inverse cosine function. So, angle between these two vectors is 105.07. Again, that's just a random angle. That's nothing special. 105.07. And that's degrees. Okay, so finding an angle doesn't require anything new. It just requires doing 3 things you already know. Find a dot product, which you just learned. Find the length, which you learned yesterday. And do inverse cosine, which we did that. We've done that a lot. Okay. Any questions on that? No. All right. So, I told you that there's 2 special cases that can happen with vectors. They can come out perpendicular. The word that you're going to see, and I don't know why, but it's the word they usually use when they talk about vectors, is orthogonal. Orthogonal just means perpendicular. That's all. So on the test I say, tell me if the following 2 vectors are orthogonal. All I'm asking is, do they meet at a 90-degree angle? Now, there's a shortcut to figure out if two vectors are perpendicular. That's the symbol for perpendicular, just an upside down T. You don't actually have to go through all the work. I mean, you can. You can go through all the work and figure out the angle is 90. Or you can do the shortcut that I'm about to show you. All right, what did I just say? If two vectors are perpendicular, what does perpendicular mean? The angle between them is what? 90. So start with that. You would already know the angle. What's on the other side? A fraction. Specifically the dot product over the product of the lengths. Okay? It doesn't matter what it is. Well, let's just say somehow when you did that out, you already knew the answer was going to be 90 because we're saying that they are perpendicular. Well, simplify that left-hand side. Cosine of 90 is 0. So if your vectors were perpendicular, that means the left-hand side would have to come out to 0. There's only one way that a fraction can ever equal 0. How can that happen? If it's 0 over a number. It's the only way that a fraction ever comes out to 0. If there's a 0 in the top. Well, go back and look at our formula. The dot product is what's in the top. So if the dot product comes out to 0, then your vectors are automatically perpendicular. Doesn't matter what's in the bottom, because 0 divided by anything equals 0. And if your fraction equals 0, then that means the cosine, the angle has to be 90. Has to be. So, let's see if these two vectors are perpendicular. So all we have to do is find the dot product and see if it comes out to 0. Okay. How about Maddie? What would be the first two things I multiply together to find the dot product? Yep, 2. And there is a 1 in front. If you want to put it there, you can. Most of the time, you're not going to see it. 2 times 1 plus Riley. What's the next 2?
2 times 1.
So remember, we want to make sure you put the number with V first and then the number with W second.
1 times 2.
Yep. So, how about Isaiah? What's the dot? 4. So Stephen, are they perpendicular?
Yes.
How come?
Because they try to stay.
So what did we say about the dot product if they're going to be perpendicular?
They both equal 0.
No, not they both equal 0. We said if they're going to be perpendicular, then the dot product comes out to 0. Right? The dot product here came out to 4. Since that came out to 4, didn't come out to 0, those are not perpendicular. I don't need to go any further. Okay. I don't know, that doesn't tell me what the angle is. I have no idea. All I can tell you is it's not 90. Does anybody see what I could change to make them perpendicular? If you could just change one thing.
One of the
Yeah, you could. It doesn't matter which one. Make any one of those a negative. Right? Make that a negative 2. Now it's negative 2 times 1, which is negative 2 plus 2. You just put a negative in anywhere, it would make them perpendicular. So it wouldn't require a big change, but the way they are, they're not perpendicular. Let me scroll down. So the other special case is parallel. Okay? For parallel, there's really 2 ways that can happen. These are parallel. 2 vectors pointing exactly the same way, they would never cross. And these are parallel. Those are 2 vectors pointing the same opposite ways that would never cross. What do you think the angle is between these 2 vectors? Yeah.
There is not.
Yeah, it would be, I drew it like that so you could see it, but what it would really look like is they'd be right on top of each other. So that would be an angle of 0. Now these other two, you could draw like this if you wanted. What's the angle between the two on the left? 180. So, in order for two vectors to be parallel, there's two things that can happen. They either point the same way, or they point in opposite directions. So 0 or 180. Unfortunately, there really is no shortcut for parallel. You just have to do the problem and see what the angle comes out to. But perpendicular, there is a nice shortcut. Right. So let's determine if those two vectors are parallel. Two vertical lines is the symbol for parallel. That's Mr. Pellet. All right. Does anybody need to see him? Is there a reason? All right. Dot product. Anthony, what's 4 times 20?
8.
80. Negative 5 times negative 25. The negatives cancel. So Emily, what's 5 times 25? 125. Add up 80 and 125 and you get 205. So there's your dot product. Length of V. Abigail, what's 4 squared?
16.
Yep. And negative 5 squared?
Negative 20. Or 20.
Yep, 25. And that's the square root of 41. Okay, so we got that. And W. A little bit bigger. We'll see if we can do this. Sebastian, what's 20 squared? Think of like,
100.
think of what's 2 squared, but then add 2 zeros.
400.
400, yeah. 25, negative 25 squared, if you type that in, is 625. Okay, so now we got everything we need. We're going to check and see if the angle is, what could the angle come out to if they're parallel?
0.
0, 1, 8, that's what we're hoping for. And then the answer to the question will be yes or no.
Big square base.
Okay.
What?
All right, so our angle. What trig function is it? It's always this trig function we use, cosine. I didn't make you go through the proof. You're welcome. So cosine of theta equals, and now we put the fraction on the other side. What goes in the top? 205. And then in the bottom, square root of 41 times square root of 1025. Now, let's simplify the bottom first. Watch what happens here. Square root of 41 times square root of 1025. 205. I had 205 in the top. That's kind of a hint that something special is going to happen. What's 205 divided by 205? 1. And what would be my last step? Inverse cosine. Inverse cosine. So let's see what the inverse cosine of 1 is. Second, inverse cosine 1. That's an angle of 0 degrees. So are these vectors, are they parallel? Yeah. So determine if the vectors are parallel. The answer is yes, they are. Now, I'm not going to do one with where they come out to 180, but let's take the inverse cosine of -1. That's 180. That means this would have to come out to a -1. How can a fraction come out to a -1? We just saw how it could come out to a +1. But how would it come out to a -1? Yeah.
If you have either the numerator or the denominator as an
As long as you have a positive in the top and a negative in the bottom and divide it always.
You can only have one negative on either the top or the bottom.
Right, so as long as I have just a negative in the top and in the bottom and I divide, you always get -1. Anything else? I can give you an example of a positive divided by a negative that's not -1.
150.
Right, they have to be the same, they have to be opposites, right? So, in order for a fraction to come out to -1, you have to have opposites. Like 12 divided by -12, something like that, okay? Now, can the dot product ever come out negative? Yeah, dot product can come out negative, depends on the original numbers. The bottom are lengths. Can lengths ever come out negative? No. So the only way that you could ever get a negative in that fraction would be if it was in the top. You will never have a negative in the bottom. Okay? So if the angle is going to be 180, then your top number has to be negative, and the bottom number has to be the opposite of that. But there's no quick way to figure that out. You gotta do it out and see if they come out opposites. Right? Especially if the square roots get kind of big. Like I couldn't tell in my head that square root of 41 times square root of 1025 is 205. It's too big. Right. Any questions on that? Okay. So that's the dot product. All right. So the homework for tonight, it's on 352. It's 7 to 17 odd. Each question has 3 parts. I think they asked you to find the dot product, find the angle, and then say if the vectors are parallel or perpendicular or neither. So it's not like they're separate. You got to do one to do all 3 of those anyway. Right, so just make sure you do all 3 parts. Find the angle, find the dot product, and then tell me if they're parallel, perpendicular, or neither.